In this video, I'd like to talk about the math question of the day for Monday, July 3rd, 2023. And with this problem, we need to find the missing side length x in this right triangle here. And finding missing side lengths in right triangles, which involves the Pythagorean theorem, is often taught in grade school, maybe 6th, 7th, or 8th grade, though sometimes you might not see this till geometry once you get to high school. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start going through this. And like I mentioned, we need to use what's known as the Pythagorean theorem to find a missing side length in a right triangle. So let me write that out. The Pythagorean theorem, named after the mathematician Pythagoras, who was Greek. This theorem relates the sides of right triangles. So if we have some general right triangle, where this angle is the right angle, the 90-degree angle, and let's say we know the side lengths, the legs are A and B, and we know the long side, which is known as the hypotenuse, is length C, then the relationship between these is that we square each of the legs and add them together, and then this is equal to the hypotenuse squared. So a squared plus b squared is equal to c squared is typically how students will remember this, though if you want, you can use different letters here. Now, I won't prove this theorem. Remember, a theorem is something that is proven true, but there are well over 100 different ways that mathematicians have proven this to be true. So if you're curious, feel free to look one of those up. I have made a video on one of those proofs in my series on Euclid's Elements. Now, we just need to apply this theorem. So we need to assign the legs as A and B. It doesn't matter which is which, but the hypotenuse, that has to be C in this formula. So let's say 5 is A, x is B, and our hypotenuse is this long side C, which is 6 in this case. And like I said, if you want to switch A and B, that's completely valid. So let's now match it up to our formula here. We have A is 5, so we have 5 squared plus B squared, that is x, our missing side length. We're squaring that. And this is equal to C squared, which is 6, and we will square that. And at this point, we can start simplifying everything. 5 squared, 5 times 5 is 25. We still have x squared, and 6 times 6 is 36. Now, we need to solve this equation for x squared. So let's subtract 25 on each side so that we can cancel this out on the left-hand side. 25 minus 25, that's 0, so we're just left with x squared. And 36 minus 25 is 11. Now, to get x by itself, we need to get rid of this square here. And canceling out squares, the operation that allows us to do that is taking a square root of each side of the equation. So if we take a square root of each side of the equation, then when you have something squared and you take a square root, you end up with the number on the inside, ignoring the square and the square root. For instance, if we had the square root of 3 squared, 3 squared, remember, is 9, and the square root of 9 is 3. So the square root and the square canceled each other, and we're left with just 3 here. So on this left-hand side, we will just get x. Let me write that over here. We have x, and on the right-hand side, we get the square root of 11. Now, I do want to mention that technically there are two solutions to this. The square root of 11, the positive version, and negative square root of 11. Since minus root 11, if we multiply that by itself, the negatives cancel, and root 11 times by root 11 is just 11. We end up back with what we started with. However, this is a physical side length, so because of that, we are just concerned with the positive version of this equation. So our missing side length, x, is simply the square root of 11.